Hello my dear students of third prep. Today we are going to continue the main trigonometric ratios. But today we are going to have the main trigonometric ratios of some special angles. Why we used to say that they are special angles? Because their triangles are of special ratios which are not found in any other triangles. Let us start our lesson today. The main trigonometric ratios of some special angles. Let us see if you have an equilateral triangle ABC of side length 2L and we draw AD perpendicular on BC like that in the figure opposite to you. An equilateral triangle, all its sides are equal, each of them is symbolized as 2L. And from the vertex A, we are going to drop a perpendicular AD perpendicular on BC. Then, what about measure angle B? Of course, yes, measure angle B equals measure angle C equals 60 degrees. Why? Because the measure of an angle of equilateral triangle is 60 degrees. So measure B equals measure C equals 60 degrees. Then you are going to notice that the perpendicular AD will bisect the base BC. So we can say that BD equals DC and each of them is symbolized as L. So BD equals L. Then what about AD? When you use Pythagoras theorem in triangle ADB, you are going to make Pythagoras theorem or use Pythagoras theorem, and then by taking the square root for both sides of the equation, you are going to find that the length of AD is square root 3L. Then, to find a ratio between BD, AB, and AD, the three sides of the right angle triangle, you are going to notice that they will be L ratio 2L, which is the hypotenuse, ratio root 3L, which is the length of AD. So the ratio between them by reducing or dividing the three parts of this ratio by L, you are going to notice that the ratio will be 1 ratio 2 ratio 3. It means that the ratio of BD will be 1, the ratio of the hypotenuse will be 2, the ratio of the third side, which is the perpendicular AD, will be square root 3. That's correct. It's a very important rule. The ratio between the three sides, BD, AB, and AD, will be 1 ratio 2 ratio square root 3. Now, to find sine 30 degrees, sine any angle will be opposite over hypotenuse, its rule. So when you look to the previous figure, you are going to notice that the side opposite to the 30 degrees, its ratio is 1, and the hypotenuse, its ratio is 2. So we can say that sine 30 degrees equals 1 over 2. In any triangle, even if its measures are 30 degrees and 60 degrees, of course, but with different sides, you are going to obtain a ratio finally as 1 over 2. Then what about cosine 30 degrees? It's adjacent over hypotenuse. So it is square root 3 over 2. And finally, what about tan 30 degrees? It's opposite over adjacent, which is equal to 1 over square root 3. Then, what about to find sine 60? All of you know that the rule of sine is opposite over hypotenuse. Then, what about the side opposite to the measure of angle 60 degrees? It is, of course, yes, the side of length root 3. or of ratio root 3. What about the ratio of the hypotenuse? It is 2. So sine 60 equals root 3 over 2. By the same way, we can find cosine 60, which is equal to adjacent over hypotenuse. What's the ratio of the side adjacent to the angle of measure 60 degrees? Its ratio is 1. And the ratio of the hypotenuse is 2. So cosine 60 equals 1 over 2. What about tan 60? Tan is opposite over adjacent. So the opposite to the angle of measure 60, its ratio is root 3. And the adjacent, its ratio is 1. So tan 60 equals root 3 over 1, which is root 3. Now you are going to have a note. What's this note? Note that in such a figure, sine 30 equals cosine 60. Yes, both of them equals 1 over 2. So sine 30 equals cosine 60. And sine 60 equals cosine 30. Root 3 over 2. The other is root 3 over 2. You are going to notice that sine 30 equals cosine 60 and sine 60 equals cosine 30. Then, if you divide sine 30 by cosine 30, you are going to obtain a result as 1 over root 3 by dividing. And 1 over root 3 is exactly the same as the ratio of tan 30. So, did you notice? Sine 30 over cosine 30 equals tan 30. This will lead us to a very important note, which says that sine theta over cosine theta equals tan theta. So sine an angle over cosine the same angle equals tan the same angle. This is a very important note. Take good care of it. Now, ABC is isosceles triangle and right angle triangle at C, where AC equals BC, as the figure in front of you. Then, I want you to complete measure angle A. What about measure angle A? You are going to notice that it is isosceles triangle. So measure angle A equals measure angle B. So we can say that measure angle A equals measure angle B equals 45 degrees. Then, can you find the length of AB, which is the hypotenuse, by using Pythagoras theorem, of course. So AB to the power of 2 equals BC to the power of 2 plus AC to the power of 2, which is L to the power of 2 plus L to the power of 2, to obtain a result as 2L to the power of 2. By taking square root for both sides of the equation, you are going to find that AB equals square root 2L. Now, to find a ratio between BC, AC, and AB, it is a ratio between L, L, and root 2L. By dividing this ratio by L for all its parts, you are going to obtain a result as 1 ratio root 2. So the ratio between the length of the two equal sides is 1, 1, and the ratio of the hypotenuse will be square root 2. In this case, we can say that sine 45 degrees, the sine is opposite over hypotenuse. What about the side opposite to 45? Its ratio is 1. What about the ratio of the hypotenuse? It's root 2. So sine 45 equals 1 over root 2. By the same way, what about cosine 45? It is adjacent over hypotenuse. The ratio of the adjacent is 1. The ratio of the hypotenuse is root 2. So cosine 45 degrees equals 1 over root 2. And tan 45 by the same way, opposite over adjacent. The side opposite to angle of 45, its ratio is 1. And the adjacent, its ratio is 1. So 1 over 1 will give a result as 1. And here we can say that tan 45 degrees equals 1. Find the value of cosine 60 degrees, sine 30 degrees, minus sine 60 degrees, tan 60 degrees, plus cosine square 30 degrees. As we have studied before, you are going to find that cosine 60, yes, it is equal to adjacent over hypotenuse, which gives a result as 1 over 2. What about sine 30? Yes, it's opposite over hypotenuse, which gives a result as 1 over 2. Then what about sine 60? Yes, it is opposite over hypotenuse to obtain a result as root 3 over 2. What about tan 60? It is opposite over adjacent, which is root 3 over 1 to obtain a result as root 3. Then cosine square 30, you are going first to find cosine 30. Cosine 30, it is adjacent over hypotenuse, which is root 3 over 2. Then to find cosine square 30, you are going to square root 3 over 2. So it is root 3 over 2 all to the power of 2 to obtain a result as 3 over 4. By substituting, you are going to find that. Then to find cosine 60 sine 30 minus sine 60 tan 60 plus cosine square 30, you are going to substitute. What about cosine 60? Yes, that's correct. Cosine 60 equals half times. What about sine 30? It's half minus. What about sine 60? By looking at the figure opposite, you are going to find it. Yes, that's correct. It is opposite over hypotenuse, root 3 over 2, times tan 60, which is root 3, plus cosine square 30. Cosine 30, what about cosine 30? It is root 3 over 2. And to find cosine square 30, you are going to square the root 3 over 2. Then you are going to find a result as 1 over 4 minus 3 over 2 plus 3 over 4 to obtain a final result as negative 1 over 2. Now we are going to have another example. Prove that sine square 30 degrees equals 5 cosine square 60 degrees minus tan square 45 degrees. Here you have two sides. You are going to take each side separately, find its value, and make a comparison between the two answers. If they are the same, so you proved the required. If not, try to solve it once more so as you have something wrong. First of all, I'm going to start by cosine 60 degrees. What about cosine 60 degrees? It is 1 over 2. Its ratio is 1 over 2. Then what about sine square 30 degrees? Yes, it is equal to sine 30 equals half, and by squaring it, half to the power of 2, you are going to obtain a result as 1 over 4. Then what about tan 45? First of all, tan 45 equals 1. So to find tan square 45, it's 1 to the power of 2 to give a result as 1. Now try to find the second part. Sine square 30 degrees equals 5 cosine square 60 degrees minus tan square 45 degrees. First of all, we are going to find sine square 30. Sine 30 equals half. By squaring it, it's half to the power of 2. to obtain a result as 1 over 4. What about the other side? 5 cosine square 60 degrees minus 10 square 45 degrees. Cosine 60, that's correct. It is 5 multiplied by 1 over 2 to the power of 2, which is 1 over 4. Minus 10 square 45, which is equal to 1. You are going to find a result as 1 over 4. By making a comparison, both sides have a result as 1 over 4. Another example, find the value of sine 43 degrees. Look carefully to this angle, 43 degrees. Is it one of our special acute angles which we have studied? Of course not. It's a different angle. Oh, we are going to learn also the other angles, their sine, cosine, and tan? No, of course not. You are going only to learn 30 degrees, 60 degrees, and 45 degrees. So what about 43 degrees? Yes, we are going to use our calculators. If the angle is different than 30 degrees, 60 degrees, or 45 degrees, you are going to use your calculators. How can you find sine 43 degrees? By pressing on your calculators the bottom sine 43 and press the bottom degrees, then equal. You are going to obtain a result as 0.682. So the value of sine 43 degrees equals 0.682. Then what about cosine 53 degrees, 28 minutes? You are going to use also your calculators because it's an angle which is not from the special angles. You are going to press the bottom cosine, then 53, the bottom degrees, 28, the bottom degrees, which is expressing minutes. And then you are going to press the bottom equal to obtain a result as 0.5953. What about tan 64 degrees, 37 minutes, 49 seconds? By the same way, press the bottom tan, 64, press the bottom degrees, 37, press the bottom degrees also, which expresses minutes, 49, press the bottom degrees, which expresses the seconds, then press the bottom equal. You are going to obtain a result as 2.1089. Another example, finding the angle given its trigonometric ratio. Here I'm going to give you the example, but in the opposite way. I'm going to give you the answer and I'm asking you for the angle. How? First of all, what about sine 33 degrees? By using your calculators, you are going to find that the result is 0.54463. If I gave you that the sine of any angle, for example, angle A, equals 0.54463, how can you find that the answer will be, or the measure of the angle will be 33? Also by using your calculators. Now, let us have an example. Sine E equals 0.6. Now, I gave you that the result of sine an angle, I don't know it, equals 0.6. And I'm asking you, what about the measure of this angle? It means that I'm giving you a converse problem. So you are going to use the calculator conversely. How? Instead of pressing the button sine the angle, you are going to press shift sine. Shift sine 0.6. Then press the button equal. It will give you an answer, maybe in decimal or in degrees. If it is in decimal, you are going to press the bottom degrees. So measure angle E will be 36 degrees, 52 minutes, 11 seconds. So, to find the measure of the angle, you are going to press on your calculators, shift sign 0.6 and then equal, and finally press the bottom degrees, so as to be written in the form 36 degrees, 52 minutes, 11 seconds. If it is cosine E equals 0.6217, yes, you are going to press what? That's correct. You are going to press shift cosine 0.6217 equals. You are going to obtain an angle of measure 51 degrees, 33 minutes, 35 seconds. Then, what about tan angle E? It is equal to 1.0823. So, to find measure angle E, press the button, shift tan 1.0823. You are going to obtain measure angle E equals 47 degrees, 15 minutes, and 48 seconds. Then, complete. If you have a question, complete. Sine x equals half. I want you to find angle x. By the same way, press the button, shift sine half. You are going to obtain that measure angle x equals 30 degrees. If the problem is sine x over 2 equals half, exactly the same as the previous, instead of x there is x over 2. You have found in the previous problem that x equals 30. What is the number divided by 2 gives 30? It's 60. By the same way, you can say that shift sine half equals what? Yes, it is equal to 30 degrees. Then x over 2 equals 30. So you are going to obtain a result for measure angle x as 60 degrees. Then, if 10x plus 10 equals square root 3. By the same way, press the button, shift 10 square root 3. That's correct. You are going to obtain a result as 60. It means that x plus 10 equals 60. So x equals 50 degrees. Another example, find angle A if sine A equals sine 60 degrees, cosine 30 degrees, minus cosine 60 degrees, sine 30 degrees. Of course, yes, to find angle A, you must find sine 60, cosine 30, minus cosine 60, sine 30. First of all, sine A equals, what about sine 60? It's root 3 over 2. Times, what about cosine 30? Root 3 over 2. Minus, what about cosine 60? It's half. Times, what about sine 30? It's half. By using your calculators, you are going to find that sine A equals half. By using your calculators, shift sine half, you are going to find that measure angle A equals 30 degrees. By the end of this example, we have reached the end of our lesson today. I wish that all of you understood it. Try to practice, solve more examples, and we'll meet next lesson. Bye-bye.